So now we need to remember that there are global parameters that we can set at the start of a series of experiments and leave them fixed at those values as we alter other parameters. And then there are local parameters that we vary step by step as we go through an experiment. Here's an example for neural networks, which you'll cover with Dave later on. Here's an example for decision trees that we're covering currently in the labs. So when you click in the classifier area, you open up this parameter box, and when you click on more, it will give you some textual information about the parameters. We're not so worried about global versus local splits in decision trees because they're much more efficient to actually train than neural networks. So we can afford to handle the variation locally as we go. But things we should consider are selecting the kind of pruning that we would use. That is something that we would fix over a series of experiments. Considering the kind of pruning, we can use confidence factor, which is the default setting for the C4.5 decision tree. We can use a minimum number of objects, and both of those can be active confidence factor and minimum number of objects at the same time, although we would only vary one at a time. So typically we would keep minimum number of objects at 2 and reduce confidence factor over a series of steps to increase pruning. Alternatively, we could leave confidence factor at 0.25 and increase minimum number of objects over a series of steps, also to increase pruning. Alternatively, we could switch these out and use reduced error pruning instead. If you want to use some of these alternatives, you'll need to read up on them in the literature and decide whether to try using them and your justification for using them. Another parameter that we could set globally over a series of experiments is binary splits. So we can choose with nominal or categorical attributes to use a binary split instead of a multi-way split. So instead of splitting across on the different values of the attribute, it would pick one value versus all the rest. Sometimes binary splits are considered to produce better trees. Again, read up on this in the literature before deciding to do it. Having completed our decisions, we've done a series of experiments, so we analyse our experimental results, present our findings to our client, and implement if given the go-ahead. So we compare the different components and the architectural variations on them. So from a set of decision trees, we pick the best. From a set of neural networks, we pick the best. From a set of Bayesian classifiers, we might pick the best. And then we compare the best from each to decide which version produces the best results. We use statistical tests which Weka can perform to decide whether the results are meaningful or whether they could have just arisen by chance. We check for overtraining. Suppose we get 95% accuracy on the training set and 65% on the test data, then we know we've overtrained on the training data and it will not generalize well to real-world solutions. Look at classification bias in the contingency table. Suppose we get 99% accuracy on one class and 65% on the other. The average accuracy will look okay. If 65% is the dangerous result in a clinical test, then this is not a good solution to implement. Decide which are the most usable and easiest for humans to understand. For example, a small decision tree can be quite understandable to a human, but a small neural network can still be difficult. Also, which solutions are most computationally efficient? For example, a few years ago, when we had a major flu outbreak, the NHS mounted a Tamiflu system to determine whether you needed Tamiflu or not. This was getting 8 million hits a day when it was first mounted. So then we formulate, tabulate, and present our findings in a manner that a non-technical user could understand, a manager in a client organization. Having got a go-ahead, we then implement the best solution. We are unlikely to use Weka or MATLAB to implement a solution. We are likely to code a native solution in a programming language, or we can generate code out of one of our tools. For example, Java can be generated from Weka, which can be embedded in a Java shell to produce the overall solution. Then we can have our celebration on project completion, and remember, non-alcoholic beers are also available.